Hello makers, hope all are doing well. My name is Abhay PA. I will be the host for the today's edition of MakerChat. MakerChat is powered by MakerGram. MakerGram is an open community platform for makers and hardware enthusiasts to share, learn and collaborate. This is our 7th edition of MakerChat. If you are joining for the first time, don't worry, all the previous editions are recorded and are available at our YouTube channel. So let me move on to our today's topic. Today's webinar will be on how to learn machine learning for humans by Gopikrishnan Sasikumar. Uh, he is currently working as a machine learning engineer at FullContact and running the project initiatives for TinkerHub Foundation. He completed his bachelor's degree in computer science engineering from Rajiv Gandhi Institute of Technology, Kottayam. He is an active member in tech communities and doing amazing work by helping students, guiding and mentoring them. This webinar is focused on machine learning with available methods and resources. Before the session begins, I request all the attendees to mute the video and audio for an uninterrupted session. Thank you once again for everyone joining the session. Over to you, Gobi.
Hi guys. First of all, thank you MakerGram for giving me this opportunity to conduct this Maker chat. And yeah, so as you all know, machine learning and artificial intelligence is an area where there's a lot of potential and opportunities these days. And our today's session will be about how to learn machine learning and how to learn machine learning and getting an opportunity or job in this field. So this kind of thing. So without further talks or anything, I'm just heading to our main topic. Hope all of you can see the screen.
Yeah, your screen is visible.
Yeah, cool. So let's start. So Salman first asked me to conduct a session on how to learn machine learning for humans. So based on current scenarios, I thought about adding some, making it available for aliens too. So yeah, so this session is basically about a learning path that worked for me. That might work for you too. So it is just a general structure you can follow. You can make tweaks and you can make some changes in the learning path. Basically, do whatever works for you. The goal is to um, learn machine learning and then build projects, work with the machine learning. So whatever way works, but this is a general structure I followed. So starting with the programming knowledge. So machine learning, machine learning or artificial intelligence, when we talk, is not actually an area that is totally focused on computer science. Is not an area only for the computer science people. It is an area where its potential lies in various fields like robotics, like medical field, space research. Everywhere, machine learning and artificial intelligence have applications. But it's a subset of computer science, and you are building machine learning and artificial intelligence using computer codes. So that's what basically you are doing. So computer programming is a necessity for learning artificial intelligence or machine learning. So first of all, programming knowledge is a must. And then second thing is still we are using Python. Python is the mostly used programming language for machine learning. It's always good to start with Python. So if you are new to programming, then maybe you can directly get started with Python. Or if you're coming from a C++ or JavaScript or other background, that might be an advantage for you. So you have the programming basics, like some concepts. So you can then go to Python and get set with Python knowledge. And so in Python, you need to have basics of things like, say, variables, conditions, loops. So these are general stuffs uh, in programming language. Every programming language have this kind of things. So obviously you must have that knowledge. Then, but most importantly, when you learn Python, you should be able to understand, or you should be able to do these kind of things like installing packages, installing Python, and importing packages. That kind of things you should be able to do. That's a key thing everyone should focus on. And then you need to know how to write functions in Python. Functions are called methods, and then things like using decorators, then maybe object-oriented programming, like class inheritance. These things are important. So one of the sources I would like to recommend for you is this book called Automate the Boring Stuff. God's link is not found. Maybe automate the boring stuff.com. Yeah. So you can go to, you can use this book, Automate the Boring Stuff with Python for, say, getting started with Python. So here there's all the things I mentioned in the before is here. You can use this book and you can try out the exercises and codes in this book to get yourself comfortable with the Python. And then moving on, then we have some articles by this guy Centex. It's called Python programming.net. So here there are tons of tutorials on Python fundamentals, game development, web development. So you can just focus on Python fundamentals and maybe Python fundamentals and data analysis, and this section on machine learning. You can use that. And the same guy has a YouTube channel. So you can go to that YouTube channel and watch his YouTube videos as well. So this guy's name is Centex. So these are the two sources I used mostly. This book, Automated the Boring Stuff, and then these videos and articles by Centex. So this is very important because most of the people, before getting started with Python or any programming basics, they get started with the machine learning algorithms and try to do this, and then find out that it is very hard. But it's very important that if you have the Python or any programming language basics, then it will be easy for you to get started. And then second thing, and this is another key thing, that is installing and setting up stuff. So when you do programming, there are a lot of components you are using, like a programming language, you will be using a text editor, you will be using an interpreter, compiler, or something that you will be using. Then you will be using Git or GitHub for putting your code, or maybe getting some sample codes or packages. All these things you will be using. So there are some stuffs you need while learning machine learning, and at the same time, there are some stuffs that is not much important. So first thing is a computer running any OS. So I have received a lot of queries asking about how to learn machine learning, and during the conversation, this other person will say that I don't have a computer. Because without a computer, you can do anything. You need to get a computer. You can get a low budget computer, or you can actually build a computer. If, I read in Twitter somewhere that you can maybe if you have a problem with the money, you can buy a Raspberry Pi and you can connect this with a monitor and a keyboard, and then you can do that. So for getting started with the Python and basic machine learning, I think that will do. But anyway, you need a computer. That's the point. A high-end GPU? No. You don't need a high-end GPU for getting started with the machine learning. So most of the time, people ask me, "Bro, I'm getting started with the machine learning, and which laptop I should buy?" And the point is, I am using a, so this people will be asking like things like what GPU I should have in the system, that kind of things. But it is not necessary that you need a high-end laptop. Like you don't have to spend a couple of lakhs or something for buying a laptop for learning machine learning, because One thing is that you will not be doing that so much GPU intensive machine learning problems in the beginning. And even if you are planning to do, you have options like a Google Collaborator, and then you can get some GPU instances from online, AWS or like Google Cloud, compared to buying a 1 lakh, 2 lakh rupees laptop. I think it would be better to pay some small amount for using the GPUs in server for a particular period. So you can start with that, and then you reach a point where you need this GPU or stuff, then you can move on to buying a large laptop, a big expensive laptop. Or that time you can have other options. So I don't think you need a high-end GPU or a system with a gaming laptop or something. Basically, I am taking this session as well as using for my project. I'm using a MacBook Air, MacBook Pro, and there's no NVIDIA or any other GPU in the system. I basically use the cloud and Google Colab. So personal opinion, yeah. Then you can install. You should install Python. You can install Python directly from Python, the official website of Python. There's a play. You can go to download, and then you can find out the version. 3.8.5 is the latest version. So yeah, you can go to directly, and you can install it from there. Or there's an option called two options like Anaconda and Miniconda. So Anaconda is a basically when we talk about it's a tool for data science, and it's actually a package manager. Provide some, you can create environment, virtual environments. So when you install Anaconda, you will get a Python. You can install Python, Anaconda version of Python with a large set of libraries and packages used for machine learning, like Pandas, NumPy, Matplotlib, and a lot of packages you can install. But the thing is, it takes a lot of space. So I think the Anaconda package is of size 5 GB, more than 5 GB. So that's the thing. Ideally, you can install Python directly from Python website, or if you don't want to spend some time installing or downloading all the libraries needed separately, you can just use Anaconda. And then for some packages, installing Python packages in normal method fails. Say, for example, in Windows machines, because there will be some problems like setting path and everything. So I think Anaconda, with Anaconda, there's some advantages like that, installing packages smoothly and using smoothly. Yeah. So if you have a problem with this large size of Anaconda, then you can install Miniconda. It's a bootstrap version of Anaconda. With it's a minimal installer with basic packages. So you can install Miniconda, and it's just a say 55 MB size thing. Yeah, so yeah, that's it. And then you, after installing a Miniconda, you can use the command conda install package name for installing other packages you need. So yeah, that's it. And this thing is the another important thing. Using a heavy IDE like PyCharm or Spider. Guys, these IDEs are good. Like PyCharm and Spider provides a lot of functionalities and features, but I don't think you need it, because if you are installing a heavyweight IDE, PyCharm IDE, I think there's a community edition, but most of the time the other editions are paid, and if you are using without a license, then there will be a trial, and then you have to do other methods like cracking, or I don't understand why we need to go to that extent. So the thing is, this PyCharm and Spider-like IDs, they are heavy with a lot of features, and most of those features you might not be using much, even for Python programming or for machine learning. So I don't recommend, again, personal opinion, I don't recommend using heavy IDEs like PyCharm or Spider for getting started. So you can always go for small IDEs like Visual Studio Code. This is my favorite. Or you can go for IDEs like, say, Sublime Text. This is another personal favorite. So these IDEs are simple, very simple IDEs. You can install it, small size, very simple and good looking, but small size. That's it. And make sure you integrate the installed Python with the IDE so that this can happen. Like when you install Visual Studio Code, so you can see this. Like so when you type something, you can have this thing. This is called IntelliSense. So that when you type something, the editor will show the possible next line. So in that way, you can have an idea like how this thing works, like yeah, that kind of things. So what is next? What all possibilities are there? Because in school and college, what we normally do is we just by heart this code and do the write it in the lab and everything. That's not how things happen in the real world. In the real world, people will be using IDs, documentations, and everything, so you don't have to by heart everything. So that's key. And for God's sake, please don't use Notepad for coding, because Python is an intended programming language. So instead of braces, curly braces, we are using indentation. So it's like a tab. So if you are using notepads or something like that, then it will always throw unnecessary errors. So always install something like a Visual Studio Code. Yeah. So what you need to do is, in the first steps, you need to install these things, Python and IDE, and integrate this IDE with Python, and then start learning basics of Python. Then install all the packages, maybe Python and some other basic packages. Then start learning how to write Python functions, how to write Python class, how to do inheritance. These things you should learn. And then the next step with the programming is, it is recommended, but not necessary. You should build a Python project and open source it, so that you can evaluate your Python learning, and you will get an idea about how a normal Python project is done. Because there was a time where there's a post called Data Scientist, where this guy will sit with some Jupyter notebooks opened in browser and do the machine learning part. That job is not going to be here for long, because right now industry need machine learning engineers. That means people who know how to build web application, backend web application with Python, and machine learning, and a bit of Docker, Kubernetes, that kind of things. So that's what industry need. So you need to learn how to build a Python project, and as well as maybe how to build a backend web application using Flask, Django, or Responder. Yeah. So this is not it's not a must for getting started, but recommended. And moving on, then you can get started with the machine learning algorithm and its mathematics. So basically, these above parts, that is learning Python programming and learning machine learning algorithms and mathematics, can go parallelly. Say, for example, if you are taking a week, for 3 days you can learn the Python programming. Then for next of the 3 days you can learn ML algorithms and mathematics. Alternatively, maybe like the first day you learn Python, second day you learn one of the algorithm, third day you learn Python, like that, and the seventh day you can go Rust. So you can do that. So yeah, that's it. And then when it comes to the truth about mathematics, you need some basic knowledge in mathematics, like the school level stuff, so like the things you learned in high school and higher secondary, like linear algebra, probability, differentiation, matrix multiplication. I forgot to add. I will add it when this session is finished. Yeah, like 4 things: algebra, probability, differentiation, and matrix operations like multiplication and addition. So these skills are necessary. You can use your textbooks from schools or college to brush up your math skill. So this is something important, because without this, I don't think you can make it to learning these machine learning algorithms. And then the next step is to learn these machine learning algorithms. So there are tons of algorithms. I'm just saying machine learning, so that deep learning, reinforcement learning, supervised learning, unsupervised learning, all this comes under this machine learning category. So these algorithms, you can go to the internet and find out resources or implementations or equations of algorithms like linear regression, logistic regression, k-means, and KNN, neural networks, deep neural networks. You can go on to various resources in the internet. There are tons of resources. Um, it's not coming up to my mind which resource to share, but because there are tons of resources. You can just Google and find out. And you can, what you need to do in this part is you should read about these algorithms, and in your mind you should understand how these algorithms work, like various components of this algorithm, so like the loss functions or cost function, and you should get an understanding. It will take some time. The reality is that I took a lot of time understanding algorithms. It takes a lot of time, but you can hold on and spend some time, learn this algorithm. It's okay, take some time and learn these algorithms, understand these algorithms. So there is this awesome repository of machine learning tutorials with this guy Ujjwal Khan. So you can find about an introduction and a lot of algorithms like genetic algorithms, statistics, and then deep learning, linear regression, logistic regression. This is one example of where you can find some algorithms like decision trees. So you can go to this awesome repository, or you can go to Udacity, Coursera, or to any course and understand this algorithms and the mathematics behind it, basic mathematics behind it. And yeah, product. I told you that you can have a basic understanding of probability algebra and stuff like that, and then on the go while learning an algorithm, say for example deep neural network, there's a lot of differentiation operations and chain rules in neural networks. So you can have a basic idea about differentiation, and then during learning about neural networks, you can, when you get stuck with this differentiation or like some complex operation or mathematics, then you can stop the learning there, and then you can go to brush up your mathematics skill. So that's a very good idea. That worked for me very well. So you can learn everything about machine learning, and then learn everything about mathematics, and then coming back to machine learning. That's not going to work. Now the next step is this is important part. You should learn how to implement this machine learning algorithm. So you can go to various websites and use articles or books, and then learn how these algorithms work, and then try to implement these algorithms with the vanilla Python. Vanilla Python means without using much of a higher level libraries like scikit-learn. You should be able to implement some basic algorithms like maybe linear regression, logistic regression, a small neural networks using NumPy, Pandas, and Matplotlib library. So these are some integral parts in doing this part. So there are resources like maybe neural network in 11 lines of code. No, 11 lines of Python. There's a tutorial called this. You can write a neural network in 11 lines, where this guy Andrew Trask used Python and NumPy for building a toy neural network. Okay, so I will add this resource to this repository. So yeah, so the goal is to use these packages, NumPy for numerical computations, Pandas for data pre-processing, Data pre-processing means like maybe loading this data set from a CSV file, or maybe from an SQL database, or maybe from a Google Sheet. You can use pandas. Then matplotlib for plotting. So in this part, you should be able to understand, you should learn these three libraries, NumPy, pandas, and matplotlib, and then try to implement these algorithms, linear regression, logistic regression, and other algorithms using what? Using Python. Now the next step is after doing this, you will get an idea about how to code in Python. You know how to how these basic machine learning algorithms work. Now then you can move on to implement. You know how to implement it in Python. Then now you can move on to using any high level libraries, because in machine learning we don't usually implement these algorithms ourselves. We use libraries. Then why did I ask you to learn to implement these algorithms? Because when you do this, you'll get the knack of coding machine learning algorithms, or maybe implementing or using a machine learning algorithms in Python. For getting that idea, you should be able to know how to implement these algorithms in Python. And why we are not using our own code for implementing machine learning algorithms is because our code can be slow, because Python is a slow programming language. And these libraries like the scikit-learn, TensorFlow, and PyTorch, these libraries are built on top of C++ or some fast programming languages. So C++ or C fast. So it's an abstraction built on top of C or C++, these libraries. So when you build a machine learning model using TensorFlow or sklearn or PyTorch, what happens is it will the Python is a host language where you code your models, and on running this model or training this model, this Python code will be converted to underlying C++ or C subroutines using some packages like Python, and then it is run there in GPU or CPU. So it is much faster than the Python implementation, and that's why we are using scikit-learn, TensorFlow, Keras, and PyTorch. That's one of the reasons why we are using this. Second reason is a lot of flexibility, and second thing is you have a lot of flexibility using these libraries. You can do this fast, and you can prototype fast using libraries like PyTorch or TensorFlow. So that's another advantage we have using these libraries, and there's a lot of other advantages. So what you can do is you can start learning any of these packages. Maybe you can start with a scikit-learn. Scikit-learn is a machine learning library with classic machine learning algorithms. And these two, TensorFlow, PyTorch, and many other like MXNet, Caffe, these libraries are deep learning libraries, essentially. So you can start with one of the libraries, learn from the documentations. I always recommend learning from the documentation. So when you click this content I created, you'll directly go to this TensorFlow documentation. So there are tons of resources like for beginners, for experts. Yeah. So yeah, we have that things. So you can go directly to this documentations and learning, or you can go to YouTube and search for these tutorials and learn TensorFlow, Keras, or PyTorch. Then you should start building a project. You should do a project. Python, like you did a machine learning Python project, you should do a machine learning project. So that's the next step. So why we are doing this step is, so you learned Python, so you learned machine learning algorithms, how to implement it with Python, then you learned how to use TensorFlow or Keras or PyTorch. Now you need to learn, now you need to evaluate yourself and know yourself and show off the world that you can build a Python project, machine learning project. That means you are skilled in machine learning and Python. So after all the steps, you need to go to the steps for building a machine learning project. And that's the next steps. So so maybe Abhay or Faris, is there a Q&A session, or can I continue with how to implement this, how to build the steps for ML projects?
You can continue the session. We can have Q&A
Okay, cool.
at the end.
Okay, cool. So now next is the steps for doing an ML project. So there are some steps, and the first step is finding out a problem you can solve using ML. So, so I told you that ML is not a computer science field. It's an interdisciplinary field. There are a lot of application in various fields, like a medical field, from rocket science to finding out maybe best YouTube videos, or like a lot of applications out there, from maybe classifying images to check our manga to building rockets. Machine learning has an application. So you can find out a problem. Maybe you can think about a problem that you wanted to solve, or like a real world problem you are facing, or maybe the world is facing. So first step is to figure out that problem, what you need to solve. And then when you do this step, you should do check that whether this is possible, like maybe building engine, or like building a something like the AIs and stuff you are seeing in most of the sci-fi movies. That's like not possible right now. So the first step, you need to find what problem would you like to solve using machine learning, and then second is whether it is possible. So just googling, or maybe a basic research after. So that's the power of coming all through these steps. So from this step to this step, when you reach this step, you will get an idea about when a new idea come to your mind, with the knowledge you acquired, you will get to know, you will get in a split second, or in some time you will know that whether this idea is too much sci-fi or possible, because you have the Python knowledge, or building a Python project knowledge, or some project building knowledge, so you can know, you'll understand the feasibility of that project. And the second thing is, you know how these machine learning algorithms work, and you know how to implement these machine learning algorithms. And now then you'll know whether an idea works or not, so you can choose an idea that will work. And the second step is figuring out the logic and the ML pipeline you can build for solving the problem. So this is like, so most of the people think before joining machine learning, they think that, okay, so this machine learning is end-to-end. That means you just give some data to the model, and then model will predict, okay, the output. So that's not how things happen. Say, for example, if you take a project like a Google Assistant. So you are not actually just giving you a voice. So when you give the voice command to Google Assistant, maybe you might be thinking that it is just taking the audio input and then directly giving the output. Okay, your alarm is turned on. That's not what's happening. So when you give a command like turn off your light, or turn on set an alarm for 6 a.m., what happens is it will take the voice commands, and they use voice data, and then it will convert this voice data into text data by voice to text model. It's a machine learning model. That's one model. Then after getting the text, it will do some pre-processing to avoid some noise. That is this logic part. It use the logic part, or normal coding, programming paradigms, or modules for pre-processing that text data, and then pass it to two machine learning models. One is a text, one is a intent classifier, and another is an entity extractor. So this intent classifier is a model that will classify, take the input, set an alarm for 6 a.m. and predict that, okay, this command is for setting an alarm, and not for sending a hi to Mary. It's for setting an alarm. Okay, it will classify that. And then second is an entity extractor that will take the command, set an alarm for 6 a.m. and extract the entities 6 a.m. Okay, and set an alarm at 6 a.m. it will extract. Then what happens is there will be a set of functions return these functions are the capabilities of the AI, and then based on the intent classified and entity extracted, it will do some if else operation. Say, for example, if condition is alarm, so the intent classified is alarm. Okay, so if alarm, then search for entity. Then it will go to the extracted entity. If entity is available, then set an alarm for the entity. Otherwise, else, return a question. Which time would you like to set the alarm? Okay, then in the next result, when the time is given, then check data, the input. If it is a time, then set alarm. Okay, so that's so basically every machine learning project is a logic plus machine learning model pipeline. So there will be a machine learning model, a logic module, machine learning model, logic module. So that's how basically every machine learning project looks like. Okay, so you need to figure out that plan. That's the second step. And then the third step is actually you need data set. So if you have a general idea about machine learning, then you know that machine learning is basically making sense of data. And what you are doing when compared to general programming, in general programming, what you do is you write the code and then you input the data during the runtime, and this code will process the data and give you the output. That's not happen in machine learning. In machine learning, what we are doing is in the training part time, you will create a machine learning model, build a machine learning model, and you get a data set. Give this data set to the machine learning model. This machine learning model will do the training process. Then we give you a model. Next time when you give a new input data, this machine learning model will make a prediction. That's what happened. So data set is an integral part. Say for example, you are building for your project you are doing is a COVID-19 classification. So COVID-19 classification. So what you need is you need to maybe take some data like the temperature or some sensory data or something like some data, and then what you need to do is you need to predict whether this person is affected by COVID-19 or not. It's a bit sensitive topic. Or maybe your project is like it's in a CCTV camera. So what you need to do is your CCTV should analyze all the people walking through and make sure whether everyone is keeping the social distancing. Okay, so if any two people are not keeping the social distancing, then you need to recognize their face and then send them a penalty, like the police guys do in traffic. So traffic cameras will catch you if you are violating a rule, and maybe in some countries it will detect your face or maybe the one number, and then it will send you the fee you should pay to your house. So like that, you can build this model. So for that, what you need is, for this social distancing, what you need is image data set. Okay, so one place where you find the data set for your project is internet. So in the internet you can find, maybe you can find data set like in a collected data set, or maybe data set that is spread through the internet. So you need to write some script and everything. So there are two places you can go to find some data sets. So one is this Google data set. Say maybe let's search social distancing images, physical distancing actions for reducing the spread of COVID-19. So yeah, so one data set is available. So there's another data set like a data from social interactions to. So there are tons of data set available here. You can go to each of these data sets and see if these images, if data sets are images of people doing social distancing or not. And another option is using Kaggle datasets. Is another platform where you can go and see download open datasets. So here you can search maybe social distancing dataset. So maybe, so yeah, you should be able to find some data set here. So yeah, so maybe that's one case. So you can search for a data set and see if the data set is available here. Okay, so Kaggle, Google data set and Kaggle data set are two options. So if the data set is not found in the internet, yeah, cry out loud if you don't find for a specific problem. This happens a lot because the data set for a specific problem may not be available in internet. Because some problem sets are unique and you might not find the sufficient data set uh, for doing your project. So no, this is not the only option. So there are a lot of techniques you can use, like you can collect the data sets using cloud source. Say, for example, you can talk to, you can connect with the government authorities, and you can say that you are building a project like this, or you need data from CCTVs, or maybe you can actually go to YouTube videos and get the images of cloud and then annotate it yourself. Or if your data is something like, say for example, one of my friends in college did this project for Malayalam character classification. So what he did is he created a small Android application where using the Canvas, something like a Canvas API. So people can take the phone and then people can just write to this like a car, and then select the option car and click save. So this data set, so the image of handwritten car and the label car will be sent to the Google Sheet, sent to a Google Sheet or database. Okay, so you can build a small application and send it to your friends or people for collecting data set. People will help you. Friends will help you. That's what friends are for. So friends protect each other. So you can do that, or maybe you can build a Google form and share it with the people. So that's it. So collectively you can do this. So always, if the data set is not available, then you can use these techniques, and make sure when you complete the project, if it is an open source project, or if possible, make sure that you publish this data set in one of these platforms, Google data sets, or like or Kaggle data set, because the same pain you faced will be faced by other people. So contribute and help each other. So yeah, that's another step. Now the next step is train, evaluate, tune, and repeat. So after collecting this data set and building this machine learning model, you can then use a pre-trained model or build a new model, and then pre-process the data set you collected. You need to do a lot of pre-processing techniques, like you need to convert the color images to black and white for using less computation, or maybe you need to reduce noises, like you need to, there are a lot of techniques, or sometimes the painful parties, you need to manually pre-process all this data. So if you are enjoying the advancement of machine learning or data science, you should give a hats off to people working in platforms like Amazon, Mechanical Turk. These are platforms where people manually pre-process the data and get money. So people from Amazon Mechanical Turk and platforms like Cloud Factory, and those annotations engineer in Tesla, Google, and Microsoft, these people are why you have the large available public data set where you can use that kind of data for learning and building a model. So you should respect, and you should give some hats off to these kind of people. And yeah, so that's it. And then pre-process the data set you collected, and then train and test these models. Okay, you can train this model with the data set and then test it. And you need to do the hyperparameters. When you go through the tutorials, you'll know what hyperparameters are. Basically, these are parameters that will make sure the model works perfectly. So yeah, hyperparameter tuning. And after this is a repeated process. So train, evaluate, tune, repeat. So after repeating this process, you will get a machine learning model. And after getting this machine learning model, the next big step is wrap this in a web application or a mobile application. This is important. You can't just put some code and this model in a. You can't just put a you put your code in Google Collaborator or in a Jupyter Notebook and put it in GitHub, because nobody. I don't think that people like companies or people that actually people who to machine learning makes sense will not be looking in that kind of stuff, because you need to make sure that the thing you built is available and usable by people. So that's why you can build a web application using Flask or Django, or you can use a mobile application and put to this model, and they're all maybe the most wonderful choice is buy a Raspberry Pi, buy a microcontroller like Arduino, and then you can actually now put your machine learning models into these kind of things. You can build your own robots using these machine learning. So do that. It's wonderful. And the last and most important step is open source your project, whether it is a basic machine learning model that classify whether an image is of a chakka and manga, or whether it is a problem, whether it is a AI model that will compress a large file into KBs like in Silicon Valley TV series, whatever it is, just open source it, or maybe you can either you open source it or publish it and make some money. Do either of this step, because uh, maybe you learned machine learning, you learned Python, you learned machine learning, you built this project, but no one will know. No one will understand that you learned machine learning from two, 3 lines in your resume or LinkedIn. Nobody care about that, these kind of things. So people need to see your projects and people need to see your work, actual work. So that's why you need to put your either you need to put your project in GitHub, open source it, or you can publish this project as an application or a service. You can put it in Product Hunt. Product Hunt is a wonderful place where you can put your projects and get some attention and traction. So that's a very important step. So these are the steps, and after completing these steps, maybe you will take some time, like 3 months to 6 months to maybe 1 year or 2 years. But I can personally promise you that if you follow these steps properly, I can ensure you that you will land a very good job in machine learning. You will be able to build a startup or a product. I'm not saying startup, a good product in machine learning. You'll be able to do that because throughout these learning path, you will get this skill set, necessary skill set for doing machine learning projects. I can promise you that. So from here, the next step is because some years ago, machine learning is a general area where computer vision is there, NLP is there, time series prediction is there. Yeah, things are there. But now these machine learning area is getting narrowed down because there are a lot of areas here. You might. So you can after following all the steps, you can maybe become a jack of all trades. Like you can learn computer vision, you can learn say what you can learn NLP, you can build projects, you can do all the steps. But maybe it will be a good idea for focusing on some particular area, like maybe computer vision or NLP. You can do that. And so that's the next step. So there are a lot of areas in machine learning happening right now. So I will talk about some of the areas. One is on-device AIML. So on-device AIML means for some time, how this machine learning work is that you take a photo in your mobile phone, or you take a or your sensor in your sensor, IoT sensor, temperature sensor in your home will sense this temperature, and then it will send this data to servers via something like an internet module, or maybe Yeah, and then in the server, this machine learning model will run, and then it will send back the result. If you are a guy who used to, this applications like Prisma back then you can see, you might be remembering Prisma used to take a lot of time for sending this image to the server and get back the result. Now it is not storing, so now it is just fast with the real-time filter. So how that happens is it is happening by on-device machine learning. So on-device machine learning means instead of doing that, like I said, on-device machine learning, in on-device machine learning, what happens is this machine learning algorithms runs inside the inference process. So there's training and inference. Training is when you train the machine learning model. Inference is when you just give the input and get an output. So this in giving input and getting output part will be happening in your mobile instead of happening that, instead of giving this to your device and sending to the cloud and getting back. So that's called on-device machine learning. And on-device machine learning, for that, a lot of libraries. Apple used this library called CoreML. It's available in Apple, like Xcode and Swift. With the Xcode and Swift, there's this library called TensorFlow Lite. You can build inbuilt or on-device machine learning applications in mobile devices, or maybe like in Android, Flutter. You can do this with the TensorFlow Lite. I think there's something called TensorFlow.js. You can do this in web now, like you can do machine learning in browser as well. And then recently PyTorch is a library focused on machine learning research. So they also built something called PyTorch Mobile. So you can use, I think most of the libraries, almost all the libraries, existing libraries, provide a mobile version or a light version for on-device computations. Next key thing is privacy preserved machine learning. So I told you that in on-device machine learning, the training happens in the server, and then they will send back the machine learning model to your device. So then after that, these inference process will happen in device. So privacy preserved AI ML focus on, instead of sending the data from clients to training it in the server, the training process also happens in the mobile devices. So in on-device machine learning, only the inference process happens in on-device, but in privacy preserved machine learning, what happens is the training process with the help of techniques like federated learning will help you do the training in the device. So what happens is, instead of taking your data from every mobile devices to the server, the model will come from the server to client, learn the new patterns or new data from the client side, and go back to the server. And one model, and then we can be, then the on-device computing can happen, or maybe server-side computing can happen. Basically, but the training process will happen in the machine, in the client side instead of server side. So so that means privacy. Your data will not be going from your mobile to servers. It will sit in your mobile devices. Yeah, that's it. So there are two popular tools available. This package called PySwift and by OpenMind, and then this by TensorFlow. These two libraries are actually getting started, but what I can say is this is the first wave. You remember this guy, MKPhD. Why this guy is so popular is because he came to YouTube and he started the YouTube video in the first wave of YouTube videos. So that's one key reason. Other than his marvelous skill set and passion, the first wave thing is a key reason why he got very popular, and he's the best in this area. So like that, privacy preserved AML and on-device machine learning, these areas are having a first wave. So this is the, if you get started with these two areas right now, you have a future. You have a great future because you can contribute to OpenShift, sorry, PyShift and TensorFlow Federated, or maybe you can build it for the, maybe you can be the people who built the first applications or first tools with these kind of things. You can be that guy or that person, and yeah. So that's the thing. Then I told you about computer vision and NLP. Uh, there are tons of tutorials. You can either focus on computer vision or NLP, or maybe you can focus on computer vision and NLP. It's your choice. And then there are applications in robotics and edge computing. Like there are tools like OpenAI Gym. OpenAI is a company created by Elon Musk. So OpenAI Gym is a simulation tool for training reinforcement learning algorithms, basically used for building robots. So you can use OpenAI Gym for training these simulations, for simulating your robots or robotic hands, or maybe something like this weird looking stuff. Yeah. So yeah, you can do that. And then I told you about this libraries like TensorFlow Lite. So TensorFlow Lite is available for Arduinos, like different kind of tools, like maybe mobile devices as well as this IoT devices. So recently TensorFlow Lite is available for microcontrollers as well. Means, so basically, I remember talking to Salman about MicroPython. Salman once introduced me about to MicroPython. So basically, before people used C++ or embedded C or something like that for coding microcontrollers, then this MicroPython came. So with MicroPython and then TensorFlow Lite and some C++ libraries, now you can put your machine learning models in microcontrollers. Crazy, right? Such a small chips running machine learning. So that's another cool area you can go on. So after learning machine learning and building projects in and getting getting literate or getting an idea about how to the basics, the foundational elements, you can either focus on this. You can, maybe it would be nice focusing on one of the areas. These are just some of the areas, but there are tons of areas like maybe medical imagery, medical health informatics, and space research. A lot of areas are there. So yeah, you can, maybe it would be nice if you narrow down and focus on one area. Yeah, so what I can say is there are tons of opportunities. I know stupid people saying, "Oh, the time of machine learning is over. That cold winter is coming," whatever. But still, current state of machine learning algorithms works, and it's not actually the general intelligence stuff, but it can solve a lot of problems, and there are still a lot of potential. And so yeah, that is so now is also the time for getting started is not over. You can get started with the machine learning, focus on stuff and build projects, get a good job. There's a lot of potential available in machine learning. And yeah, I'm concluding my talk with one more point. So I'm seeing that a lot of fake machine learning courses around Kerala, like a lot of organizations and institutions or maybe companies putting courses for a huge amount, like you have to pay 1 lakh or 50,000, that kind of amount. That's huge. And but if you check out the contents and everything, that's not much good content. But the people training you are not that much efficient. They might be some people. Maybe I don't know. I'm not anyone to judge, but no, I don't think going for such such places is not a good idea. I can assure you that majority of the machine learning algorithm part, even including programming this GPU, like this CUDA programming stuff, NVIDIA has a lot of free available tutorials and stuff. So from the lower level part to higher abstract libraries like Keras, there are tons of free and open source learning materials. Make sure you utilize that kind of tutorials, and don't go to for like fake stuff, so like maybe courses offering you for 1 lakh or something. Okay, so there are nano degrees available for such course. Those are good. Nano degrees are good. Nano degrees from Udacity, Coursera, it's worth spending some time and amount for such courses, and utilize the free courses and resources available. But do not go for maybe some organization in your native place, or maybe some organizations that are not those are not universities or any colleges or anything. So please don't go for that. These are, I don't think these are good. You please save your money and go to all these already available free open source tutorials and YouTube videos. Utilize it, learn, spend as much as time you want. Nobody's going to ask you why you spend this much time. Nobody's going to ask you that. Spend whatever time you like, work hard, and then learn through these materials, and then start doing machine learning projects, apply for jobs, opportunities, take sessions. If you are in college, take sessions. I made a lot of money when I was in college, taking sessions for partying and maybe for my eating good food and traveling. It was fun. So you can still do that. Maybe after COVID, or you can take online sessions, create contents in YouTube, do projects, build projects. Yeah, that's it. So happy learning and all the best. Yeah, thank you. So thank you, MakerGram, for giving me this opportunity.
Thank you, Gopi, for your wonderful session. We have a couple of questions from Facebook Live and in the chat section as well.
Yeah, maybe
we can do one thing.
Stop my share. Yeah, maybe you can see you can show the questions, right? Or maybe you can ask the questions yourself.
Yeah. I will read out the questions and the name of the questionnaire. The person who posted the question, and you may answer the question. The first question we have is from the Jomon Thomas. He posted that on our Facebook Live. It is the question is, what about using Collab for basics? I think he posted that at the beginning time of the session.
This is a personal opinion. I'm not a good fan of Jupyter notebooks, because Jupyter notebooks, with the Jupyter notebook, you can run third line and fifth line without executing first line and second line. It doesn't make sense for me, because it is not how basically we program, because it's not a sequential execution, and that's why I don't use Jupyter notebooks much. But Google Collaborator is a free platform where you can train your machine learning models. It's free from Google. They will only take your coding data and do it. That's another story. But you can use Google Colab for training your models. But I don't prefer using Jupyter notebooks. I'm not a good fan of it. But you can learn, and you can build your machine learning models in Python and using some IDEs like Visual Studio Code, and then import it in a file in Jupyter notebooks as a package, and then run it in Google Colab. That's a beautiful place where you can train your models. A lot of people, including me, using Google Colab for training for personal and private projects. You should use Google Collaborator. It's a good platform. Yeah.
Okay, thank you. And the next question is from Rajat Khatri, and he's asking is, how can we connect database like MySQL or MongoDB, which can continuously feed the model for training and prediction?
I didn't properly understand the question. Did he mean?
I will read it again. Okay. He's asking is, how can we connect databases like MySQL or MongoDB, which can continuously feed the model for training and prediction?
Okay, so he means that collecting this data from a database like MongoDB, and then feeding it to machine learning model, right? Or
yeah, exactly.
Okay, so you can use libraries like Pandas, or maybe I don't know. I haven't used a Spark. There's some tools called a Spark. I haven't tried out Spark yet. Maybe Spark is used for maybe this kind of distributed training and kind of things. So you can couple Spark jobs and TensorFlow or maybe other libraries, and you can do that. I think when I get more details, I will just put it in the this
MakerGram forum.
Yeah.
So the next question is from Abel Koshi Matthew. He's asking, can you mention some of the subfields in ML?
Yeah, the subfield is supervised learning, unsupervised learning. Supervised learning deals with the labeled data. Unsupervised learning with the unsupervised data. Reinforcement learning. These are the classic classifications. And then subfield other than this is deep learning, deep reinforcement learning. Like I said, there's computer vision, NLP. These deals with images, videos. Computer vision deals with that. NLP deals with natural language, then voice recognition and speech, machine learning on speech data is there. Then areas like on-device machine learning, privacy-preserved AI, machine learning on edge computing like devices like Arduino, Raspberry Pi, and then time series prediction like some sensory data, like say for example, I have a gloves or a wristband which will take my sensory data, it will sense it in my hand movement. That means if I'm maybe I am unable to speak, I can the sign language signal is taken. So these data are called time series data. It's a series of data points. So this time series prediction or time series classification is another task, another area. So these are some of the areas. So there are tons of areas. It's getting larger. So you can Google and find out. And these are some of the basic areas in there. Subtasks, subclasses in machine learning.
Thank you for the detailed answer. And the next question is from Nikhil Jones. He's asking for suggesting some courses from Udemy for learning the machine learning. I think you already mentioned some of them at the ending part, right?
Yeah. Maybe you can look into that material. Yeah, cool.
Okay. So another question is from Abhijit Kannan. So he's asking for self-driving cars, the machine learning needs to process data really fast. Since Python is slow, will it give an output too late? Or if the answer is no, how do they solve this issue? So I think he's curious to know about the performance of Python when that is getting used for an area like self-driving cars where the performance.
Yeah, so that's what I said, that I don't think Python is used like maybe it is converted to lower level. This libraries like TensorFlow and PyTorch. If you try out, works faster, and they have this companies. Larger companies have even advanced levels of advanced libraries built on top of TensorFlow and PyTorch that will run faster. So basically what happens is they will try their best for maybe converting this into a lower level languages or lower level representations to run it fast, because this is very dangerous. Like getting slowed down is not an option in areas like a self-driving car or maybe a multi-million-dollar rocket. That's where exactly. C++ and that kind of, so that's another option, like on-device computation. There's another area where you should people build a machine learning in C++ and lower level libraries. So the applications comes there.
Yeah,
that's how they do that.
Okay, cool. And next question is from Salman Farid. So he's asking is how to distinguish between machine learning, deep learning, and artificial intelligence.
Okay, so artificial intelligence is like maybe there are multiple definitions for this, but what I think is like it's like we are mimicking intelligence or some level of intelligence. So there are artificial intelligence and artificial general intelligence. Artificial general intelligence means AGI, like human level intelligence, which we are nowhere near, perhaps. We don't know. Maybe tomorrow some guy will say that, okay, bro, I invented AGI. So AI means mimicking the intelligence. So whatever applications that comes from maybe a small chatbot that will take your input sentence and match it with some database, and then giving you output. If that chatbot complete Turing test, finished Turing test properly, that is an AI. Same with self-driving cars, anything that use anything that mimics some level of intelligence, is an AI or artificial intelligence. And artificial intelligence can be any techniques, like from maybe pattern matching, pattern mapping. That's one possibility. Machine learning is a subset of AI, where say a set of algorithms that derived from statistics, automating statistics, maybe that's machine learning, like this, where we make sense of data and learn from this data, and using classic algorithm, classic statistics techniques, and probability techniques, I think most of you are familiar with the bias algorithm, bias theory, and then other statistics techniques like regression. So that's machine learning. And deep learning is doing machine learning with the help of neural networks. So that is deep learning with the large layers and large computational operation. Neural networks, then that is deep learning.
Okay, thank you very much for the deep explanations for all the questions we got so far. And if anybody have any questions, if anybody have any questions pending, they can post it under the thread in MakerGram forum, and Gopi or anybody else will be attending that after.
I'll be there. Also, I will share this resource I created. Maybe I'll share you the link. You can it will be available in MakerGram, so you can find out the link from there.
Yeah, we can post that under that thread. Yes, thank you, Gopi, for your time and effort you put in for this wonderful session, and thank you all for your time for attending the session. And we have posted the feedback link and the certificate link in this chat section, and you will be getting these via email as well. You can fill the form and let us know your feedback, and let us improve for the next MakerChat maybe, and then fill the form for getting the certificate if you would like to. And then, yeah, that's it. Bye. Take care. Thank you, Gopi, once again. Thank you all. Bye.
Thank you. Bye.
Thank you. Bye. Take care.
All the best.